Okay, so here I'm going to talk about the notion of radians used to measure angles, what it is, and how to convert from degrees to radians. So, here I have a circle, and we can create some kind of an angle on the circle, right? Maybe this is 45 degrees, maybe somewhere between 45 and 90 degrees, something like that. So it has some kind of degree here, right, that we measure this angle with. So let's just say that this was like 50 degrees or something. Now, think about it. Why are there 360 degrees in a full revolution, right? And then why is this angle going, if it's exactly a right angle, why is a right angle called 90 degrees? And then why is a flat line like that 180 degrees, right? Who defined degrees? Why is it 360 degrees in a full revolution? Why not 100? Why not anything? Now, one of the reasons is 360 is a nice number because it's divisible by 2, it's divisible by 3, it's divisible by 4, it's divisible by 5, divisible by 6, not quite divisible by 7, but it's also divisible by 8, and let's see, 9, and so on, right, and 10, so on. So, it's a nice number because it's almost, aside from being able to divide a circle into 7 parts with a fixed degrees, you can almost divide it into any other number of parts less than 10. Right, so 360 is a nice number, and that's why degrees are measured in it. But then, in another sense, it's also not really a natural number, right? It's kind of an artificial number that people made up that just says, okay, let there be 360 degrees. It makes it easy to measure and divide the circle up. But is there a natural way to measure degrees? Is there a more natural one? And one of the things that a mathematician proposed that seems to work out quite well is the concept of a radian. Okay, what does a radian mean? Is that, well, I have a circle here, and it has some radius. And then, similarly, when I go along the circle, it's going to have an arc length, right? So this arc is going to have some length. And so a radian is saying that, let's define 1 radian to be exactly the length of 1 radius on the arc of a circle. So it's not going to be to scale, but I'm going to guess like, maybe 1 radius length is around there. So let's let this arc length be r. And so this is going to be described as 1 radian. Right? So here it's going to be 1 radian or 1 rad. Okay, so then what does this mean for us, and how do we actually, what is the difference between radian and degree, and how do we actually map it between the two? Well, now, how many radians are there in a full circle? Well, remember, it says 1 radius length is 1 radian. So, how many radii length are around the full circle? Well, that just becomes like, what is the circumference of the circle, essentially, right? And the circumference of a circle, if you recall, is going to be pi times the diameter. As a matter of fact, that's where the, so here is the whole diameter of the circle, so d. And of course, if you recall, and then the whole thing around is going to be the circumference, c. And so if you recall, just the definition was that pi was defined by the circumference divided by the diameter. And of course, the diameter is 2 times pi, so this means that c over d is c over 2 pi, or so d is 2 times r, so c divided by 2 times r, and so multiplying that side by 2r, we get c is, the circumference is 2r times pi, or 2 pi times r, around. So the circumference of a circle is 2 pi times the radius, as we know, just by the definition of pi. And so then it says, well, how many radii length are there around a full circle? There's going to be 2 pi radians around the full circle. So that means in a full revolution around the circle, it's going to have 2 pi radians. Okay, so that's good. Now, how do we actually convert between radians and degrees, right? So here it says, okay, full revolution is going to be 2 pi radians, and how many degrees is that going to be? Of course, the whole thing is that radians and degrees both increase linearly. So what does that mean? It means that, now that we understand radians and how we obtained it, I can erase this diagram. Essentially, because they both increase linearly, if here there's radians and here there's degrees, then it means that there's some kind of a linear relation between them. So, if here is 360 degrees, then here it would be 2 pi radians, right? Okay, so now, if I had, like let's say I had, okay, it's not the scale, but let's say it's 180 degrees, how many radians is that going to be? Well, because it's a linear thing, we know that essentially, let's call the number of radians here from 180 degrees x, and so it says, okay, x, so actually if you see here, like 180 degrees, here, like this length here is the same as this length here, right? So this is going to be 180 degrees, or actually this height here, so 180 is the height, is going to be the same as this. And then 360 is going to be the same as that. So you see there's two similar triangles, and again, as we know from similar triangles, it says that, well, 180 degrees is 2x, as 360 degrees is to 2 pi. So if we just solve this for x, move x to the other side, multiply by 2 pi, and divide by 360, we get that 180 degrees times 2 pi, and then we divide it by 360 degrees, right? And so 180 is just exactly half of 360 degrees, so it'll be 1/2 times 2 pi, which is going to be pi. So that means a radians for 180 degrees, it's going to be exactly equal to pi radians. Now, what about an arbitrary degree? So here I have some, again, let's say we had d degrees, and then I wanted to convert it to some x radians. Well, it's the same thing, we do, okay, so x is the d degrees as 2 pi is to 360 degrees. And this means that x is just going to be equal to d degrees times 2 pi over 360 degrees. But then, 2 pi, the 2 and the 360 actually cancel a little bit, so we can simplify that into just d degrees times pi over 180 degrees, right? Okay. Well, that's pretty simple. You just, use the, again, that's not an x, that's multiplied. So it's pretty simple. So that means if I have any kind of degree and I want to convert to radians and vice versa, I can just use this conversion factor of there's pi radians and 180 degrees. So if I wanted to do, okay, what is 90 degrees? Well, then that means that x is going to be 90 degrees times pi divided by 180. And then this is, well, 90 is half of 180, so it becomes pi over 2. So 90 degrees is exactly pi over 2 radians. Similarly, we can go the other way, because if we just multiply the reciprocal of this on the other side, get that, d degrees is going to be x times 180 degrees over pi. So one thing to ask you is, okay, how many degrees is pi over 3, right? How many degrees is that? Well, let's just plug it in for x. So that means that d degrees is going to be pi over 3 times 180 degrees over pi. The pi's cancel, and we do 180 degrees divided by 3. and that is going to give us 60 degrees. So pi over 3 is the same thing as 60 degrees. So, have we really introduced anything new? No. We introduced this new measure of length that's sort of more natural than degrees, because it's not arbitrary like 360 degrees in full revolution. We're saying, how many radii length does it take to get to this angle on the circle? And so it's measured in terms of radii length. But even if we don't remember that, we just have to remember this conversion factor that there's exactly pi radians in 180 degrees. And so we just plug it in and convert back and forth. And yeah, just by the conversion factor, and we will be able to translate back and forth between radians and degrees. And so generally in the beginning, for students starting to learn trig, it's easy to work in degrees. So you may want to, whenever they give you something like pi over 3 radians, you just directly convert to degrees, do 60 degrees, and then just do arithmetic by that. But once you get used to it, you'll start to recognize common ones like pi over 3, pi over 4, and pi over 6, and so on. And those are common degrees that occur over and over again. So you no longer have to convert it to degrees, and you can directly start to work in radians. And it actually makes work much easier as the time goes on. So in the beginning, it's okay to just convert to degrees for everything. But as you go on and build experience, then you can directly start to compute in terms of radians. And it actually makes things a lot easier when you do that.